In 8.5, rationalizing the denominator of radical expression. So for some reason, I don't know, some mathematicians decided that radicals in the denominator are not okay. You have certainly learned how to rationalize the denominator when it's just a square root in the denominator. So it's actually pretty easy. So let's say in number 1, our final answer is 2 over the square root of 5. We cannot leave that square root of 5 in the denominator. I don't care about radicals in the numerator. What we care about is radicals in the denominator. So let's think about how we could get rid of that square root 5. Let's go back to thinking, what could you multiply the square root of 5 by so that your answer would not be a square root anymore, right? Remember, we can multiply a square root, we can multiply a square root by itself to make it cancel out, right? But when you are multiplying a fraction by something, you have to multiply the numerator and the denominator by the same exact thing, so it essentially stays the same fraction. It's just going to look different. Okay, so my answer would be 2 root 5, and the reason why this works is because square root of 5 times the square root of 5, remember, you multiply insides with insides, that's the square root of 25. And your answer just becomes 5 in the denominator. Now you could just skip that middle step right here that I just did, and you could just know that when you multiply the square root of 5 times the square root of 5, the square root's going to go away, and then you're just left with the number on the inside. So from here we actually can't simplify, right? Just like with multiplying and dividing, you could only simplify insides with insides, outsides with outsides. Well, 5 is outside of the radical, so it can't simplify with the 2, which is also outside the radical. Since the 5 is outside in the denominator and there's a 5 inside the radical in the numerator, those cannot cancel out, and this is literally our final answer. So in number 2, remember when we have a square root that looks like this, it's the same thing as saying the square root of 5 over the square root of 8. Okay, now I need to get rid of the square root of 8 in the denominator. So again, we're going to multiply, I'm going to use a different color. We're going to multiply by the square root of 8, okay? So when you multiply, again, a radical by itself, it's going to cancel out the square root, and it's going to just take out whatever was inside, right? Because I have two 8's being multiplied together, creating a perfect square. So now I'm going to multiply root 5 times root 8, right? We could do that because those are both inside of the radical, so I get the square root of 40 over 8. Again, because 8 times 8 is 64, the square root of 64 is 8. Okay, but then you need to fully simplify your answer. So I could break up the square root of 40, right, into perfect squares. So let's say 4 times 10, right? The square root of 4 is 2. So I have the square root of 2 root 10 over 8. Now we need to make sure that our answer is fully simplified, which I could see that 2 and 8 are both outside of a radical, so I could actually simplify those. So that 2 is going to go away, this 8 is going to become a 4, so my final answer would be root 10 over 4. Now again, I cannot simplify the 10 and the 4 because the 10 is inside of a radical and the 4 is out, so we literally just leave our answer like that. Okay, number 3, so this one is slightly different because now I have something extra inside my radical, but that's not going to change the process. I'm literally still going to multiply by that radical exactly. Okay, whatever's inside of that radical is what you're going to multiply by. So I'm going to multiply the square root of 2x over the square root of 2x. So this is just going to become 4 square root 2x. It's not going to multiply inside because the 4 is outside of a radical. Okay, and then in the denominator, I get 2x, and then we simplify from there. Okay, so the 2 will simplify with the 4, and my final answer would be 2 square root 2x over x. Do not cross out those x's because one x is in the radical, one is not, so you cannot touch them, right? Insides with insides, outsides with outsides. Okay, number 4, same process. So I see 21x and y inside the radical, so I'm going to multiply that by the numerator and the denominator. So in the numerator, I will get 14 square root 21xy over 21xy. Okay, and then we check to see if we could simplify, which we can. We could divide both of these by 7, so this becomes 2. That becomes 3, so my final answer is 2 square root 21xy over 3xy. Okay, number 5. So this is where people start to get a little bit confused. I do not care about this 5 in the denominator. Okay, that 5 does not bother me. What bothers me is this square root of 7. So I'm not going to multiply by the entire denominator. Okay, I don't need to multiply by 5 root 7 because I don't care about the 5. What I care about is that square root 7. So what I'm going to do is just multiply by just the radical and what's inside it. Okay, so I just need to multiply by the square root of 7. I'm going to do that by the numerator and the denominator. Okay, so this becomes 2 square root 21, right? 3 times 7, those are both in the radical, and over 5 times 7, right? That 7 is going to come outside of the radical. So we got to multiply by that 5. So this becomes 2 square root 21 over 35. Okay, I'm going to show you a side note again of why this works. So if I had to root 21 over 5, and then the square root of 7 times the square root of 7, that's the square root of 49. If I kept simplifying this, right, the square root of 49 is 7, and we would then have to multiply by that 5, and we'll end up at our same answer right here. Okay, so you could do it either way, but it's good to get in the habit of realizing that when you multiply a radical by itself, the square root's going to cancel out, and you're left with the number inside, right? So if you have the same of a number as the index, right, so the index is 2, so if I have 2 of the same number, that number is going to come outside of the radical. That's why it works. Okay, so when we are rationalizing denominators with nth roots, so it's something higher than 2, okay, we need to create a perfect power that will get rid of that radical. So here I have a cubed root. So I need to create the next perfect cube that will get rid of the cubed root in the denominator. Okay, if that makes sense. So for example, what would create a perfect cube with number 2? Well, that's multiplying the number 2 by itself 3 times, right? You're looking for that number that matches the index. So I'm looking for the same number 3 times. Well, I only have 1, 2. So that means I need to multiply by 2 more 2s. So 2 times 2, right? Well, essentially 2 more 2s, that would create 4. So I'm going to multiply by the cubed root of 4. Okay, so that becomes 3 cubed root of 4 over the cubed root of 2 times 4, that's 8, right? So that simplifies to 3 cubed root of 4 over, which the cubed root of 8 we know is 2 because we created that perfect cube by multiplying 2 by itself 3 times. Okay, and that's our final answer because there's nothing else we can simplify. So you could literally jump from this step up here all the way down this step knowing that you're multiplying 2 by itself 3 times because this is also 2 times 2, right? So that's what we're looking for. We're looking for that perfect power that'll make that root go away. So in number 2, I have just one b. So ask yourself, how many more b's do I need so that I have a perfect cube? Well, if I have 1, I only need 2 more. So I'm going to multiply by the cubed root of b squared. We always want to keep it at the same root, okay? So it's going to be the third root. And then I'm going to multiply the top and bottom by the same thing. Again, it's because I have b, and then this is b times b. So it's creating 2 more b so that I have 3 b's being multiplied together to create a cubed root. So in the numerator, since these are both inside of a cubed root, I'm going to combine the inside. So it's going to be the cubed root of a b squared over, well, this is going to become b cubed on the inside, right? And the cubed root of b cubed is just b. And then we're done. Okay, number 3. So again, I'm going to split this up. Let me make my thing a little bit smaller. I'm going to split this up into the cubed root of 5 over the cubed root of 9a squared. Okay, let me break this down for you a little bit so it's easier to see what we have to multiply the denominator by. So if I broke up 9, right, that would be 9 times 9, or sorry, not 9 times 9, 3 times 3. And then the a would be a times a. Well, we need 3 of the same number to create a perfect cube. So all that I'm missing, let me do this in a different color, all that I'm missing is a third 3 and a third a. So I'm going to multiply the top and the bottom by the cubed root of 3a. Okay, so I'll show you why this works. In the numerator, I'll get the cubed root of 15a. In the denominator, 3 times 3 times 3, right, is the cubed root of 27. A times a times a, that's a cubed. Now I have something that I can simplify further in the denominator, getting rid of that cubed root. So again, you could just jump to this next spot because we know that 3 of the same number, so 3 3's, will just create 3, and then the cubed root of a cubed is just a. So you could just jump from that spot to this spot, but I was just kind of showing you why it works. Okay, so again, you're looking for the same amount of the same number as your index. Okay, and then there's nothing on the outside that I can simplify with the 3a, so that's literally your final answer. You can't simplify inside of the radical with something outside of the radical, so we have to leave it like that. So in 4, I have a 4th root, right? So I'm looking for 4 of the same number. Well, I have 1 3, so I need 3 more 3's to create a perfect 4th power. Well, we know that 3 times 3 times 3 is 27, so I have to multiply by the 4th root of 27 in the numerator and the denominator. So I get 5 4th root of 27 over, again, let me make a side note, this is 3 times 3 times 3, so I have 4 3's, so the 4th root of 27 times 3, which is 81, so the 4th root of 81 is just 3. Can't simplify the 5 and the 3. Can't simplify 27 and 3 because 27 is inside the radical, so then this is our final answer. Okay, same thing with number 5. So it's a 3rd root, so I want how many more 4's to create a perfect cube? Well, that's 2 more 4's, right? 4 times 4, which we know is 16. Okay, so I get 6 cubed root of 16 over 4, right? Or 4 times 4 times 4, which is 64, and the cubed root of 64 is 4. Now, just make sure that I can't simplify further, which I can, because the 6 and 4 are outside of a radical, so this becomes 3, and that becomes 2. So my final answer would be 3 cubed root of 16 over 2. Okay, number 16. Let me rewrite down here. So this is the 4th root of 3 over the 4th root of 16x squared. So there's 2 ways you could think about this. Actually, 16 is a perfect cube. I probably should have changed that. Let me actually just go ahead and simplify what I can first in the denominator. So the 4th root of 16 is actually 2. So I get 2 4th root of x squared. So that x squared is still stuck inside of that radical. Okay, so I want to get rid of the x squared. So I need how many more x's to create a perfect 4th power? Well, that would be x to the 4th power, right? So I need 2 more x's to get that x outside of that 4th root. Okay, So since these are both inside the fourth root in the numerator, I get the fourth root of 3x squared over, right? Because now I'm going to have 4 x's all together. The fourth root of x to the fourth power is just x, and it's going to tag along with that 2. Remember, I don't need to multiply by the 2 in the denominator because it's not in the radical, so that's not really messing with my answer, right? What I care about is whatever is inside of that radical. Okay, and then that's going to be my final answer. Okay, with number 7, I have just 1 4 and 1 y. Okay, we need 3 of the same thing, so I need 2 more 4s, right? 2 more 4s, that would be 16, and I need 2 more y's, so that all together, this would create y to the third. This could create 4 times 4 times 4, which is 64. Okay, so we're going to multiply the numerator and denominator by that radical. So I get 4 cubed root of 16y squared over 4y. Okay, so if you multiply by the right thing over here, okay, you'll just be left with whatever's inside of your radical. And sorry, we are not done because we can simplify these 4's. So the 4's are going to cancel out, leaving me with the cubed root of 16y squared. And sorry, there's actually a perfect cube that lies in 16, right? So actually I could break up 16 into 8 and 2, because 8 is a perfect cube, right? 2 times 2 times 2. So I'm going to take the cube root of 8, that's 2, cubed root of 2y squared all over y. Okay, and then that is your final answer. So every time you do this, you need to make sure you are fully simplified, or else you'll make mistakes like I do. Okay, so always check to make sure you're fully simplified. Okay, and then number 8. So I only have 1, 2. I need 4 of them. So essentially, I need 3 more 2's, right? I have 3 x's, so I need 1 more x. And I have 1 y, so I need 3 more y's. So I'm going to change those 3 2's into what we know that multiplies to be, right? 2 times 2 times 2 is just 8. So it's the fourth root of 8xy to the third. Okay, so then I get 7 fourth root of 8xy to the third over. Now, since I'm multiplying by the correct amount in the denominator, I'm just going to be left with what's inside of that radical. So that's 2x cubed y. And then you're done. Okay, nothing to simplify. There's no perfect fourth power that goes into 8. Can't simplify the 7 and the 2, so you're done. Okay, now the last one is rationalizing a denominator that has a sum or difference. Okay, and all you have to do is multiply by the opposite. So I can't just multiply by root 2. Okay, I know in the other ones, all you cared about what was in the radical, but that's because there was something attached like this and we didn't have this over here, right? That's okay because that's not a binomial, so I still don't care about that 3. But now that this is a binomial, okay, this changes everything. So when I say you have to multiply by the opposite, I'm going to multiply by the same 2 terms, okay, but you're going to do the opposite sign of this. So essentially, I'm creating a difference of 2 squares. So I'm multiplying by root 2 and 7, but instead of plus, I'm multiplying by the minus. So this is a difference of 2 squares. Now think about, why would I multiply by the difference of 2 squares? Well, that's because your middle term will always cancel. And your middle term is the one thing that's going to have a radical in it, right? That's going to get rid of that radical in your denominator. So let me show you how. So essentially, I need to FOIL this out. So this becomes root 2 times root 2. We know that a radical times itself just becomes 2, right? The radical goes away, you're left with the number inside. So that's 2. Then I have root 2 times negative 7. That's negative 7 root 2. Then, then I get positive 7 root 2. and then I get negative 49. Now notice that these cancel out, right? I am literally not left with a radical anymore. And then you have 2 minus 49, which is negative 47. Okay, so because we're creating our own difference of two squares, we are getting rid of that middle term. We are getting rid of that radical. So again, I'm going to multiply by root 2 minus 7, so the opposite of this sign. And what you do to the denominator, you have to do to the numerator. Okay, so I'm going to distribute in the numerator, so I get 9 root 2 minus 63 over, well, we know that that became 2 minus 49 because my middle term went away, so I have 9 root 2 minus 63 over negative 47. Okay? And then you're done. Right? I can't combine anything in the numerator because those are not like radicals. Remember, we need like radicals to combine those. And you can't simplify the 47 with anything. Okay, so that's your final answer. So in number 2, same thing. I need to multiply by what's in the denominator, but the opposite sign. Okay, so root 6 plus root 2. Okay, so I'm going to do the trick, right? With a difference of two squares, you could square the first, square the second, and then we tag subtraction in between. It's going to be the same thing. So I'm going to do the denominator first. So I'm going to square this first term right here. Okay, so square root of 6 squared, or square root of 6 times the square root of 6 is just 6. The square root of 2 times the square root of 2 is just 2, and then we tag subtraction in the middle. Now, if you want to do it the long way, you can. It's just a little more work, but you could totally do it. And I'll show you the long way on the side of this. But for now, I'm going to now multiply the numerator. So you have to distribute that 2 root 3, right? Remember, when you multiply radicals, I don't care that they're different, but you have to combine outsides with outsides, insides with insides. So the 2 is going to stay, but then you got to combine 3 times 6, so that's the square root of 18. Okay, and then 2 root 3 times root 2. So that's going to become positive 2 root 6. Okay, so I'm actually not done because I have to simplify this radical right here. This becomes 9 times 2, right? Because 9 is a perfect square. Plus 2 root 6 over, I'm going to combine the 6 minus 2, that's 4. So I get, bring that 3 out, so 6 root 2 plus 2 root 6, all over 4. Okay, now this is where it kind of gets really annoying. Look at your coefficients. Okay, what do you notice about all of those numbers? Hopefully you recognize that 2 goes into all of them. Okay, so you could either just divide all of them by 2 or factor out a 2 and simplify from there. Okay, so if I divide everything by 2, it's the same thing as factoring. So this becomes 3 root 2 plus root 6 all over 2. Okay, and then that is your final answer. Okay, again, these 2's cannot simplify because one's in the radical, one isn't. If you wanted to factor it out, it would look like this. So take out the 2, 3 root 2 plus root 6 over 4, and then the 2 and the 4 would cancel out, and you would get to this answer. Okay, let me show you the foiling really quick before I move on to the next example. So if I were to FOIL this out, I'm going to do it over here in purple. Root 6 minus root 2, root 6 plus root 2. Okay, root 6 times root 6, I'll just show you the long way without even canceling out the radical, right? That's the square root of 36 plus 2, plus the square root of 12 minus the square root of 12 minus the square root of 4. Okay, now we could simplify things from here, right? This is a perfect square, this is a perfect square. Middle terms cancel. Square root of 36 is 6, square root of 4 is 2, and we're back to our 6 minus 2, which gets us the 4 in the denominator. Okay, so you can do it the long way. Like I said, it's just a little bit more work, or if you understand the shortcut, please by all means do that. It'll save you a lot of time. Okay, so in number 3, again, same two terms we're using, but we need to use the opposite sign. Okay, so I'm going to multiply by root x plus 5. So again, let me just distribute first. So I get 6 root x plus 30, so that's my numerator. Okay, in the denominator, I'm going to use the shortcut. Again, you could pause this, multiply it out yourself using the long way, and then going from there, or you could just follow along with me using the shortcut. So square the first term, right? So the square root of x times the square root of x is just x. 5 times 5, that's 25. And then tag subtraction in between. Okay, I don't see anything that could be I could factor out a 6, but that's about it. I can't simplify that with anything. You cannot simplify this 30 and this 25, okay? Do not bust your binomials. Same rules apply. Okay, we have to leave our answer as is, or if you wanted to, we could do 6 square root of x plus 5 over x minus 25 to see if we could simplify anything, which again, we can't. There's nothing to factor out of the denominator, so I would just stick with this answer right here. Okay, and then number 4. Hopefully you're picking up on what we should multiply by now, right? Square root of 5 plus the square root of 3. So same two terms, different sign, creating a difference of 2 squares. Okay, so in the numerator, when I distribute that root 2, I get the square root of 10 plus the square root of 6 over, I'm going to square this, right? So that just becomes 5. I'm going to square that. That just becomes 3. Tag subtraction in between. So I get root 10 plus root 6 all over 2. Now, the only way you could divide everything by 2 is if these had a coefficient of something that's divisible by 2. But remember, we can't simplify insides with outsides, okay? So we cannot simplify 2 with the 10 and the 6. We literally just have to leave our answer as is. So only if the coefficients on your radicals were divisible by 2, then we could keep simplifying further. But for now, we just have to leave our answer the way that we have it right now. Okay, right now I want you guys to pause this video and I want you to try the U-tries. Okay, when you come back, I will explain how to do them, and you could check and make sure you have like some sort of understanding of the notes that we just went through. Okay, so hit pause, try it, and then come back. The rest of the video will explain how to do these. Okay, so number 1, we just have a regular radical. We want to get rid of the square root of 7, so I'm going to multiply by the square root of 7. I get 3 root 7 over 7. Done. Okay, number 2. So this is a cubed root, right? Remind yourself that this is 3 times 3. These are saying the same thing. So I have 2 3's right now. I need 3 3's. So I'm going to multiply by 1 more 3, and I have 1y. I need 2 more, so I have to multiply by y squared. Okay, so we're looking for the same amount as the index. I'm going to get rid of this. So I get 5 cubed root 3y squared over, well, now that we're multiplying by the correct amount, I should just be left with 9y on the inside, right? 9 times 3 is 27. The cubed root of 27 is 3. Y times y squared is y cubed. The cubed root of y cubed is just y. Cannot simplify the 5 and 3 or the y. Can't simplify insides with outsides, so that is your final answer. Okay, number 3, we have our sum. So again, we're going to create a difference of 2 squares, so multiply by the opposite. Again, you could do the long way if you want. I'm going to distribute in the numerator, so that becomes 9 root 5 minus 18 over. Square this, that becomes 5. Square that, that becomes 4. Tag subtraction in the middle. Well, we know 5 minus 4 is just 1, so I'm literally left with 9 root 5 minus 18 over 1, but I'm not going to put the over 1 because we know we don't need that. Okay, and then last one. Shoot. That's supposed to be square root of x plus the square root of 4. Let me change this. Well, we'll just leave it as is because you probably did if you tried it on your own. So you multiply by x plus 4, x plus 4, so 3 x plus 4 over x plus 4. Okay, so let me show you what this was really supposed to be. This was supposed to be 3 over root x plus, I did not want the square root of 4 either, that would be silly. That was supposed to be this. Okay, so here we would multiply by x minus 4, root x minus 4. Okay, so I get 3 root x minus 12 over, square this, so I get x, square that, I get 16, x minus 16, and then we can't simplify anything from there. 3 doesn't go into 16, or there's no coefficient in front of x, so then that's our final answer. Okay, that is it for this lesson. I will be available through discussions or through email if you have any questions on this.